All right, welcome back. Today we're going to talk about file carving. We'll talk about both Foremost and Scalpel. The homework and the demonstration I'll use is going to be using Scalpel, Foremost being a little bit older, but both will accomplish the same thing. So, what is file carving? So, unlike last time when you were recovering a file based off of its deleted information, you would look to see what sectors it covered and it still had all that. What if that information doesn't exist? So in the case of ext4, where it zeroes that out and you don't have the sector list. So what file carving does is it's really much like searching for a needle in a haystack at times. What you have is you have a list of headers, known headers, and sometimes footers, and sometimes you're looking for just known structures, and you're looking through the entire drive, the entire image, for patterns that match that header, footer, or structure, and then you're recovering the file from there. So think of the header footer carving as looking until you encounter those specific bytes inside of the file, and then setting a flag there, and then continue searching until you encounter a corresponding footer which matches those specific bytes, and then taking that entire section, storing it into a file, saying it is a file of this particular type. As you might be able to guess, that is at times quite inaccurate. There's a lot of false positives, a lot of corrupted data, but it does have the potential to restore data that has been deleted and partially overwritten or corrupted in some other manner. So you have your file signatures, and these are the magic bytes. And if you're familiar with the command file from Linux, it functions the same way. It has a database of file signatures, and it's searching for that. It's exact same thing that these file carving utilities will do. So JPEG, for instance, the header always begins with FFD8FF, and the footer is FFD9, and that's the most common. There is information between there which will change because, well, a header will also typically include the height and width of the image, the number of color channels, things of that nature. So you're only looking for the beginning part, which identifies it as a JPEG, and then the footer, which is where the end of that particular file is. PNG, for instance, the 89504E47, that's the beginning of the PNG file. And the ending 4 bytes, 4945, 4E44, is IEND, which is the end of that particular file. PDFs always begin with a %PDF and end with a %EOF, so you can look for that. Zip files, those you'll notice that zip files are the same as docx and XLSX because that's really all a Word document, an Excel document, and even PowerPoint document are stored as, is they are just a zip file format which has all the information inside of that. So those all have the same header information and footer information. You'll notice that MP4s, EXEs, and DLL files, and there's a lot of other files out there, have headers but don't have set footers. So in those cases, what you end up doing is you start at the beginning and you find a header, or you find the bytes that match, and then you go until you hit your maximum file size that you can specify in Scalpel or Foremost. And that is the entire file. Now, a lot of times you'll get more data than you actually care about. Well, it doesn't matter, because if it's an executable or it's a movie file, its internal structure will say it's only this size and only play for that much. But there are also cases where you get less than what you expect. And so when you go to play the movie, it might stop halfway through. So knowing the size of the files, if you can decide or determine that from the header after you recover that portion of the file, will allow you to go back and grab more information that would be part of that. GIF, and it is pronounced GIF with a hard G, I don't care what the creator says, comes in both a GIF 87 or a GIF 89, and so the header is going to change. And so typically you would have two different specifications for the headers, one for each of those variations. And then all GIFs have a ending 2-byte sequence of 003B. So, foremost, this is one of the first ones that was created by the U.S. Air Force Office of Special Investigations. It's an older command. We'll use Scalpel. They both function equivalently. Scalpel is a little bit more updated and more functional, but both will work the same way. You give it your input disk, you give it your output folder, and it will automatically search through for supported file types. You can also specify which specific types you want to look for. So if you only want to look for JPEG or PDF files, you can also tell it to show verbose output. You can also do it from a mounted device, although this is generally not good unless you are careful to make sure that it's not that you have a write blocker or you can't write to that particular drive. So generally this would happen on a image or in a forensics copy. When it does the output, it will create an output folder, and then inside of that it will create one subdirectory for each particular file type. And so if you have 10 different file types that you're searching for, there will be 10 different folders that end up getting created and populated with those particular files. Scalpel functions very similarly. You specify an output folder. You have a configuration file as opposed to set type. So the key difference is, since Foremost is an older tool, it had hard-coded a lot of these headers there. Scalpel, they created a config file or a conf file that you can edit and add new types there. So if a new version of some video format came out, Scalpel would be able to recover it, whereas Foremost would require a application update if there is one. You can create an output folder. You can also specify a different output folder. One of the key things and one of the things that these tools do is make sure that if you try to write to an output folder that already exists, it will fail. The folder specifically has to be empty and not exist there. So the Scalpel conf file, the format is the first column is the extension, so JPG, PDF, or whatever. The Y is case sensitivity, whether or not it's case sensitive, which generally things are, especially on Linux. The next column is the maximum size of the files that it will recover. So you do this specifically like for the exe files or video files, which don't have a footer for it. It doesn't go and see the beginning part of it and then grab the rest of the drive as part of that file. So you generally have some maximum size for it, but you might end up tuning that depending upon what files it is. So if it's a digital camera which records high quality images, which may end up being several gigabytes in size, well, obviously set your max size higher than what that should be. The next one, or next part, is going to be the header, and you can do this as hex. You can do this as the actual printable bytes, if in the case of PDF. So for JPEG, they're doing a \XFF or hex FF, and then D8FFE0, and then you end it with a footer. So for JPEG, it's FFD9. There is one other flag which isn't actually on this particular slide, but there's a reverse flag that you can add in there. What that does is it runs until it sees the header, and then it reverses from the footer back, or it reverses to try to find the footer and then grab the image that way. With this, it seems to be a little bit more accurate when grabbing certain file types. Not all files support that, but it does require a specific footer. It's one of the newer flags there. So again, kind of the differences between there. Foremost is slower, Scalpel is faster. Scalpel, you can specify the types and you can create new types for that. Uses lower memory. Fragmented files, Scalpel can recover them better. Still not perfect. It's not the same as recovering a deleted file where you have a list of the sectors that they were spanning, but it does work better. And on Kali, Scalpel, you have to install it, whereas Foremost is pre-installed. But I believe that everyone had to install it at the beginning of the semester, which makes sense because, well, you're going to be using that. So um, just some of the limitations for this. So you acquire the forensics image. Never want to do it from the original device. Carving is read-only, but you want to verify that write protection is enabled. You want to select the file types relevant to the investigation. So you don't care about DLL files unless that's what the investigation really cares about. You don't care about some arbitrary files out there. You care about what you're looking for because it can take time. It can take a lot of time. And there could be a lot of false positives. And the more false positives you have, the more looking through all those and kind of discarding them because they don't contain the information and it just wastes resources. Then you execute Scalpel or Foremost against that image. 1 terabyte image, which drives now are quite a bit bigger than 1 terabyte, can take quite a bit of time. So you need to be specific in what you're looking for. Once you have that, there will be an audit log that you would analyze. And the audit log will list the files that it had recovered along with their starting sectors. So in the case of, say, a JPEG image, that if you happen to look at that file and it only grabbed half of the JPEG image, well, you'll know the starting sector of that from the audit file, so you can actually go to that sector and then start looking a little bit deeper or grabbing more information. And you can verify files or discard files if they are not relevant. And then finally, you want to document all the recorded files, offset within the image, the hash file type, whether it's intact or fragmented, and so forth. So some of the limitations, you won't get file names. I mean, because it's not using the file allocation table and it's actually looking through the file system itself. File names, directory structures, all of that, you just won't get it. Fragmented files are problematic, and so you may end up only recovering part of a fragmented file as opposed to the entire fragmented file. You will get false positives. I mean, lots and lots of false positives. And also metadata is not recovered with that. So you're just recovering the file contents, nothing else. You don't know, like on NTFS or EXT, who the owner or the group for that particular file was. So just the content. So file carving recovers files from raw data disk using known byte signatures. And it is file system agnostic, so you're just looking at the raw bytes on the drive itself. Header and footer carving is most reliable for formats with clear delimiters, so like JPEG, PDF, and zip. Scalpel, that's the tool that you should probably be using. Only recovers file contents, and you always carve from a forensics image, never from the original device, and you want to document everything, and that's where that audit file exists and why it's so useful.